All right, we're skipping over to chapter 5-2 AB, talking about slope, okay, rate of change. Our essential question is, how are slope and rate of change related, and how can you find the slope? Okay, what is a rate of change? Okay, rate of change describes how one quantity changes in relation to another, like miles per hour. Okay, how many miles per hour are you traveling? Your as your miles change, your time changes, and they change at a constant rate. Okay, if we're talking about miles per hour, that can be written as mph or miles per over hours. Okay, per is division. We talked about that a little while back briefly, but it is a division. Okay, you can write it as a fraction. A constant rate of change would be like driving at the same rate. Like if you're going to drive from here to Gainesville, and if it says, like it says here, you're averaging 55 miles per hour, then what you're saying is you're traveling at a constant rate of 55 miles per hour as you travel. So let's look at an example here. We're using a table here to show the number of miles a plane flies over a certain number of hours. Okay, find the constant rate of change in miles per minute. Um, this probably should be minutes right here, since that's what they're doing. So in 30 minutes, you've traveled 290 miles. In 60 minutes, you've traveled 580 miles, and so on. Okay, so the change in distance is going to be a subtraction. Okay, if you want to compare these two right here, how far did you go in 60 miles, or in 60 minutes, how far did you go in 30 minutes? The change in distance would be 580 minus 290. Take the bigger minus the smaller, in the time, so that in that 30 minutes right there, you went 290 miles. The same as you did the first 30 minutes. Okay? In the first 30 minutes, you went 290 miles. In the next 30 minutes, you traveled another 290 miles an hour. So you're traveling at a constant rate, 290 over 30, 9.67 miles per minute. Okay, if you want to know what that is per hour, just multiply by 60. Okay, it's like 550 miles per hour, something like that. Okay, um, so that's a constant rate of change. Okay, you're traveling at a constant rate of miles per minute. What is slope? Slope is a rate of change. Okay, slope is a rate of change. They're the same. So when we talk about slope, it's the rate of change between 2 points on a line, or it could be talking about this situation up here too. But it's the vertical change per horizontal change. Okay, vertical change per horizontal change. Technically, the equation is this right here. We use the letter m for slope. We say it's y2 minus y1. Those are two y coordinates on a graph, x2 minus x1, or we think of ordered pairs as xy. Okay, you're taking 2 points on a graph. I'll show you that in an example. Okay, but that's what you're doing there. Without getting into much more, I'll show you when we get there. Okay, so let's look at a real world example here. The table below shows the number of seconds y that it takes after lightning strikes and the number of miles x you are from it. Okay, you've heard the old thing, if you see a lightning strike, you start counting. I think it's like, some people say like it's like every 7 or every 5 numbers, like 1, 2, 3. Then you just divide that number by 7 and you can tell how many miles away you were from that lightning strike. I mean, once you hear the thunder, you start counting when you see lightning, 1, 2, 3. And when you hear the thunder, divide that time by 7 and you'll know how many miles you were. I think it's 7. So let's take a look here anyways. So if you were right there when the lightning struck, you'd hear it at the same time, or you'd be right next to it. It's saying if it was 1 mile away, okay, then the number of seconds it takes the lightning strikes until you hear the thunder would be 5 seconds. If it was 2 miles away, it'd take you 10 seconds. So they're saying every 5 seconds represents a mile away from the actual lightning bolt, and so on here. So if you want to know the slope or the rate of change here, you take the change in the y's, and here's our y's, over the changes in the x's, there's our x's. Okay, so I'm going to use these two xy coordinates here. Where we go here? 5 and 25, and then 3 and 15. It's constant all the way across, so pick any pair of points that you want. Okay, you'll get the same answer at the end. So the change, in this case here, we're taking, since this will be our x1 and our y1, this will be our x2 and our y2. So y2 minus y1, so it's going to be 15 minus 25. And then x2 minus x1 would be 3 minus 5. Negative 10 over negative 2, you get 5. Okay? If you'd reversed it, you'd have just had positive 10 over positive 2. It's still 5. Okay? So what they're saying is it's 5 seconds per mile. So when the lightning strikes, if you start counting 1, 2, 3, 4, 5, boom, you're going to hear the lightning. That meant, or you're going to hear the thunder. That meant you were 1 mile away. Every 5 seconds means you're a mile that much further away. Okay. If that's clear. Let's look at an example here. This is what it looks like graphically. We could take any one of those two charts that we just had and graph the points x and y. Here on my x-axis, we're talking about a number of shirts. The y-axis here represents the cost for those shirts. Okay. And here is the graph that represents the relationship between the shirts and the cost. And what we're saying right here is for one shirt, it costs $9. For 2 shirts, it's $18. We're not figuring in any discounts or special rates or, the more you buy, the cheaper it gets. It's just a constant. Okay. So find the rate of change. Well, if I call this x1 and y1, so I'm going to say this is 0.1. Doesn't matter which way you do it. If this is 0.2, then this is x2, y2. So our rate of change is just our slope m, which is y2 minus y1 over x2 minus x1. 18 minus 9, just pulling the numbers right from here. Okay, and again, it doesn't matter which way you did it. You're still okay. 2 minus 1. We get 9 over 1, or $9 per shirt. Okay. If you reversed these and called this 0.2 and this 0.1, then your slope would have just been this. You'd have got negative 9 over negative 1. You still get $9 a shirt. Okay. So it doesn't matter which one's 0.1 or 0.2. You get the same answer. Okay. So that slope. Now we think of slope. Think of a roof or pitch on a roof. Okay, that angle there that you're moving. That angle represents a slope. Okay, in a graph, we call it slope. Okay, in a word problem, you might think of it more as a rate of change. How fast is something moving or changing over time? It's the same thing. Okay, slope and rate of change are the same. We think of slope with lines. Okay, we use this equation right here to find that slope. And you'll get into this more when you get into algebra next year. You talk a lot more about slope of lines and how to find them. The thing here is I want you to get is that when we talk about a rate of change and slope, they're the same thing. Okay, how fast is this car going over a certain period of time? It's the rate of change. You're also finding the slope because you can graph each of those points, how far you've gone versus how fast it's taking you, time. And you can plot those points and create a straight line. Get into that more when you get to that, okay? But for right now, we're talking about slope and rate of change. All right, we'll get into that more here in class tomorrow. See you then.